Hello, welcome to my Tech Farm. I'm Igor, and Elegoo sent me Neptune 4 Max for the review, and this is a huge printer. I will start with most important specifications, and that's the build volume. 420 mm in X and Y direction, and 480 mm in Z direction. This is a Klipper-based printer, able to move on 500 mm per second speed, and 8000 mm per square second acceleration. It can heat up the nozzle up to 300 degrees Celsius too. Now I will be a little bit careful with this kind of specifications because this is still a bed slinger, and imagine if we do even that input shaping and everything with empty bed. This is huge build volume, and when we start with the printing, it will have more and more mass along the y-axis. And imagine on 500 mm per second speed that you have some thin tree support or something like that, and it is shaking along the y direction. So I think that this is 500 mm per second speed marketing value, but anyway, I believe that it is still much faster than, let's say, Ender 3 or something like that, but we will see that soon. I also got 2 spools of the yellow PLA filament from Elegoo, and I will use mostly this in the test prints. The box was deformed outside, and this resulted in some problem. 2 elements were bended a little bit, but I will show you this later. But most of the parts are well protected, and there was no other problems. This is the content of the package. So first of all, we have the base and the gantry, which are fully assembled. So the first big step will be assembling these 2 parts together. So user manual, this is the hot end, and a huge additional fan for the part cooling. Spool holder, some tools, screen, and then these are some stiffening brackets or something like that. And already mentioned 2 spools of yellow PLA filament, which arrived separately, but I saw 2 holes exactly for this kind of spools. So probably if you buy this in a package, it will arrive inside the box and not separately. Let's talk about the base first. So it still uses the V-slot wheels for the linear motion. And instead of 4, we have 6 leveling knobs which support on these yellow springs this heated plate. And I can see nice thermal insulation from the bottom, which is almost mandatory because we have a huge surface here to heat up. There are some securing holders, I think. Probably I should take them out. Yeah. And now I can see we have 3 pairs of the V-slot wheels. It uses this golden textured PI sheet, which is my favorite surface, and it is one-sided. Unfortunately, we don't have aligning pins. It will be much easier to place it in the exact same location. Nice tensioner for the y-axis belts. And toolbox. Here is some, maybe this is a USB Type-C, regular USB maybe for the USB drive, plug for the screen. On the right side, we have some additional plugs. This is for the LAN cable, and this is for the power cable and the switch. Now let's talk about this gantry. It also uses the V-slot wheels for the linear motion, and it has dual Z-axis, which is basically mandatory for this size. And also I can see some LED lights here, which is nice to have some LED lights, but probably it will drop some shadow, so I better like LED lights when they are on the head. Maybe here we also have some LEDs. I will see that later. This is the extruder, and we have a very small pancake stepper motor for the direct drive. And these are part cooling fans. We have 2 of them on each side and 2 side cooling. And yes, this is some kind of LED. We have a brass nozzle inserted, and I believe this is the hot end fan. Huge fan for additional part cooling, and I'm not sure is it operated by the software, but we have here the on-off switch, and it works on 24 volts. And this is the screen with some protection foil on it, and with the warning that we have to check the voltage if it's set correctly for our country. So I have to check is it set to 230 volts in my case. It's a little bit hard to see, but in my case it is set correctly, 230 volts. And you can find this switch on the left side of the printer. Between tools we have the USB drive and also a spare nozzle, and it has a very similar size like a Volcano nozzle. This is the timing bell for synchronizing 2 Z-axis, because when the stepper motors are off, this will keep this lead screw synchronized. Now this is completely loose, and at this moment I'm not even sure how to place the tension on it. If nothing else, then I will print some kind of tensioner here, but I will check later in the user manual. Mounting the extruder, 2 bolts from the front and 3 screws from the back side. Assembling the gantry to the base with 2 bolts from the bottom, and it's much easier if you move the printer to the side of the desk. In that case I don't have to rotate the printer. And this is the holder for the screen. Connecting the screen cable, removing the protection foil. And this is the external antenna for better Wi-Fi connection. This is the spool holder, and there will be the filament runout sensor too. And these are stiffening rods, very useful when we are printing on higher Z coordinates. To me this side looks a little bit damaged, and I noticed in the box this side was squeezed. I have to adjust the length of this stiffening rod. Stiffening rod is installed, but I still have a problem with this part here because I tried to rotate the Z-axis with my hand and it stuck. It's not so easy to rotate it. So I will contact the Elegoo and I will ask for replacement for these 2 parts, this one and on the other side. I decided not to wait until these 2 parts are sent from China. I will try to fix it. So I use 2 big pieces of steel and then I squeeze it in the vise. And I even try to use the hammer a little bit. Of course I use 2 hands just for the demonstration. With the other hand I hold the camera. And it looks much better now. And I successfully mounted it back to the printer and it looks okay. This is the aux fan for additional part cooling, very useful when we are printing with the PLA very fast. I already mentioned that belt for the synchronizing Z-axis is loose, and I decided to create something from piece of aluminum. It was much faster than just design and print it. And with this I can place a tension on this timing belt. Then doing some cable management and connecting the wires. And then I have to check the V-slot wheels because they are loose. This is for the X-axis and the one with the eccentric nut is from the bottom. And it's okay now. And this is for the Y-axis and we have 3 pairs of the V-slot wheels below it. And this is for the Z-axis and only on one side it was loose, so I just tied it and it's okay now. And then checking that the X gantry is horizontal because then I will align the bed according to this. Turning the printer on. Before I do the leveling or the connection to the network, quickly I want to check the moving of the axes, but before the first homing I can move them only in positive direction. X is working, Y working, and the Z working too. And now connection to the network, and I could do it over the cable too, it would be much faster, but first I want to try the RAN, the Wi-Fi. And it's already connected. I entered my password and there is the IP address which I can enter into my browser on my laptop and then I can access over the computer. The next step is the leveling, which is extremely important with this big print surface. It's homing in X and Y direction and now in Z direction. And first I will do the manual leveling and then automatic, because first I want to make this surface parallel with the moving path of the nozzle as much as possible. In that case the automatic leveling has to compensate very minimally. Unfortunately, instead of 4 we have 6 leveling knobs here. First I set the Z offset and after this I started with assisted manual bed leveling in all 6 points and I repeated this several times. After this I started the automatic leveling and this will create some kind of offset mesh which will compensate any inaccuracy along the Z-axis during the printing. The leveling is finished and I hope this springs really holds the position of the bed because this is quite slow process. And I have a warning here that to pay attention during the printing to the distance, just in case. Okay, confirm. Then it's time to preheat the nozzle and insert this Elegoo PLA filament. And I have the load button on the screen. And filament was changed successfully. And I found the Benchy on this USB pen drive and I uploaded this job gcode over the fluid. And it started correctly. I will start the printing. There is a layer shift along the Y-axis and I will retie the belts and then restart the printing. Stop. Confirm. I thought the belt is already tight, but it looks like here it must be tighter because this is a very big mess for the moving. And I hope this will be enough. It looks like I have the layer shift on exactly the same position, but this time I will let it to be finished and then I will analyze this object. Printed in 21 minutes, but let's analyze it now. But this is really strange to have the layer shift on the same location, and later I can see here also it has the layer shift, so definitely something wrong with this G-code, and quite a lot of ringing, so I believe these speeds or 20-minute Benchy is too fast for this bed slinger. This is now printing with 50% speed, and even this looks quite fast compared to, I don't know, NS3 and similar, and I'm very curious if I will have again that layer shift. The printing is at 73%, and it looks like it will be okay this time. The speed was set to 50%, but it was printed in 27 minutes. And this time this is perfect Benchy, great first layer and overhang, and even the ghosting disappeared, which I could see here on this faster printing, no stringing and no layer shift. Next printing will be this tool holder, printing time 1 hour and 17 minutes. The start looks good, so the bed is leveled correctly, at least here in the center. The printing is at 50% and it looks okay so far. This is really strong and robust desk, but I cannot use it for any kind of the work. It is very uncomfortable during this shaking along the y-axis of this big mess on the printer. It is hard to keep it in one place. Actually, the printing was finished much faster, 1 hour and 4 minutes. And let's analyze the object, and probably I have to flex the bed to remove it. It would be really good to have some kind of aligning pins at the end. It's a little bit hard to place it correctly back, this huge surface. This is the tool holder, and I can see they used the brim here, but I don't think it's really necessary. And also we have a support under these small elements, and this has to be mounted to the spool holder. Now the printing is okay. Here I can see some waves. I'm not sure is it visible on camera too. Maybe it's visible now. So here and also here I can see these waves, and I'm not really sure is it part of the design because I cannot see them on other surfaces. Maybe here a little bit. Maybe it's time to do some input shaping, and then maybe I'll print a few more prints from the USB drive. It goes here on the spool holder, and I'm not really sure how good is this position because it shakes a lot even on these higher coordinates, and maybe this will fall down. Not sure how stable is it. I think I still perform better this tool holder. I'm starting the input shaping in X direction, and it will be done and saved automatically. Now Y-axis. And it's finished along the y-axis too. One more printing from the stock G-code, and this will be this nut cracker. It's on two parts, one is the holder for the nut and the other is the screw. And they use the brim again here, but I don't think it was really necessary, and let's check the fitting, and it fits good. And it looks good too. And it's time to prepare the slicer, and I'm using here the Elegoo Cura, which is some older version of the Cura, and even we have the suggestion to update to newest Ultimaker Cura. And this 6 dice or calibration cube will be the first own printing, and it will be uploaded over the fluid. We have a nice preview image. The printing is almost finished, and I noticed unfortunately the brim is by default enabled, and I didn't disable it in the slicer. Let's remove the brim first, which is not too easy to remove. It sticks good to the object. And this time all surfaces looks nice. This is the bottom layer, the top layer, this is the x-axis, and number 4 is along the y-axis, and no ghosting or similar problems. On Elegoo's website I couldn't find any information about the maximal flow rate, so I will measure it using the Stefan's from CNC Kitchen flow rate test. And I will do it only on one temperature, 220 degrees Celsius, using this Elegoo PLA. It stops with the printing, and if I understand correctly, it didn't allow 200mm extruding, only 150. I'm not sure, let's try to reduce that. I will stop the test because this aux fan squeeze these objects. Maybe I will go from the front to the back. And it turned attempt where I reduced the extruding length, and from the front to the back it was finished successfully. With this Java scale I am measuring these small poops one by one. And now let's analyze these numbers. The change is not suddenly, but if you are watching where is the 5% under extrusion, it starts at approximately 21 cubic millimeters per second. The next printing will be this desktop trash can, and according to the slicer, the printing time is 2 hours and 3 minutes. And it will be printed in spiral or vase mode. This is still the first layer. It looks okay. It was a little bit too low on the first half, so I raised it 0.03 millimeters, and now it looks fine. I thought this printing in the vase mode is too fast, and I even checked in the fluid. It was close to the 18 cubic meters per second, which is quite fast for the spiral printing, but I left it to be finished and it was okay. The printing is at 77%. Printing is finished in 1 hour and 51 minutes, so again faster than estimated by the Cura. The object looks great from the first layer up to the top, so there are no problems with this spiral mode printing here, and I can feel that it is quite strong, so even if it was printed faster, I use here 0.6 millimeter line thickness, but I wasn't even close to use the whole volume of this printer. But now I print something which will use most of the bed surface. I already mentioned earlier that I'm printing these key holders for my university. These are some kind of coin replacement for the shopping cart. And they give this to visitors on different exhibitions. And this time I'll try to print 100 pieces at once. Usually I print maybe 10 pieces at once, but I'll try to use the whole bed surface almost. Cleaning the bed with isopropyl alcohol. This is 3 years old BQ green PLA filament. Using the load function on the screen. And from yellow to green the filament was changed. And the printing time will be approximately 7.5 hours. This is a time-lapse video, I speed up 100 times, and here you can see 100 pieces, their first layer, successfully printed. A perfect first layer on each side, and it started with the second layer. Quick check after 4 hours. Printed in 6 hours and 40 minutes. I also measured the noise from half-meter distance, and it was approximately 64 decibels when all fans are working, and actually the loudest is this aux fan. And then I measured the heat up time for the print bed. I heated up to 80 degrees Celsius and I measured the time, and for 60 degrees Celsius it needed a little bit more than 6 minutes, and for 80 degrees Celsius it needed more than 13 minutes. And then I disabled the heating and measured some cooling time. Here you can see the whole graph, and for example from 60 to 50 degrees Celsius it needed more than 5 minutes, which is good thanks to the thermal insulation. And for the end, what I like and what I didn't like on this printer. I will start with what I like. I really like its big print volume, and thanks to that very detailed automatic leveling we are really able to use the whole surface of the bed. The nozzle can be heated up to 300 degrees Celsius, it uses the Klipper, and with this we have other advantages. It is able to move on higher speeds, Wi-Fi or network connection, we can attach the camera and similar. I really like the toolbox here. This one I don't really like, but it can be used too, which was printed here. And I really like these LEDs, not only on the top, but also we have the LED below the nozzle. And also these part cooling fans are from the side, so we have a nice view to the printing and to the nozzle. And I really like this screen, which is great touch screen and also removable. It is very useful when, for example, I have a light exactly above it and it's reflecting. It was very useful to take it to my hand, and then more comfortable I can operate it. Now a few things which I didn't like. And one of those is that it is noisy. Man, it looks like the noise and the speeds always came together, but most of the noise is from this big aux fan. It is shaking a lot, especially along the y-axis, and I don't know, I have a feeling that it is not really for 500 millimeters per second speeds. It is fast, but not 500. I mean, that's speed of the Bamboo Lab, for example. I don't like that it uses 6 leveling knobs now. I mean, this bed could be now fixed if we trust that, to that auto leveling sensor. And also we have 6 rubber wheels. I don't know, somehow the rubber wheels and big speed for me don't go together. At least on y-axis they could use some linear rods and linear bearings maybe. I'm not sure how much it would raise the price. I don't like the slicer because this is just some older Cura, 4 point something, so not even 5 point something. I'm not sure, so if company don't want to create their own slicer, why don't just prepare the profiles, good profiles, for the Ultimaker Cura? I understand they don't like Ultimaker word in that slicer, but everybody knows that it is rebranded Cura. I don't like that I have to use the tensioner on the Z synchronized belt. Maybe because of these parts which are banded, maybe if they are not banded then we don't need the tensioner, but it is ready to create one even with the 3D printing. And for example, some small details that this big bed surface is a little bit hard to place exactly in the same position, so it will be very useful to create some kind of aligning pins in the end. And also another small thing, when we have the unload function for the filament, we always have to push a little bit down and then take it out. So this can be implemented in the software too. I know this from the manual unloading. Everybody who uses the manual loading probably sooner or later will figure out that it is much easier to push down the filament and then pull it out. In that case, it will not stuck and it will be taken out very easily. When the screen goes to the saving mode, I cannot just touch anywhere to bring it back. I have to press some button and I have to be careful not to press the stop or pause buttons. We have a touch screen, but I cannot enter some coordinate to move the axis. For example, if I want to move the bed from one side to the other, I need more than 40 presses. This is my experience with Elegoo Neptune 4 Max. Great printer for this big surface. I really like this textured PI sheet, this golden color. Really sticks good, and when it cools down, sometimes in the video, usually I didn't even wait until it completely cools down, it is very easy to remove the object. It still sticks, but just a minimal flexing and it will be removed. If you had some other experience, you know, write me a few lines down in the comment section. Thank you for watching and happy printing!